Hello guys, we are from group A. So today we will explanation about our assignment, transportation problem using linear programming. As we can see, we have 4 destination A, B, C and D. For destination A, we have 500, 650, 400. For B, 750, 800, 700. For C, 300, 400, 500. For D, 450, 600, 550. So for the demand, we have the same value. The value is 10. For the supply, for source number 1, we have the supply 12. For source number 2, we have 17. For source number 3, we have 11. So my friends will explanation the next step.
Okay, next I will explain about the solution on how to find optimal solution for transportation problem. First of all, we have to create an LP model for transportation problem, which is Xij equal to number of planes transported from source 1 to from source I to destination J, where I equal to 1 to 3 and J equal to A, B, C, D. Then we have to do minimization equation. Right, we can refer to the table earlier, then we will get this equation. So for the constraints, there are several constraints which are involving supply and demand constraints. Then for non-negativity constraint is Xij greater than 0. So for the initial table, we are using minimum cell cost method. So we have to allocate starting from the lowest cost, which is 300. And then we will get the initial table like this. So to find the optimal solution, we are using stepping stone method. So we have to allocate the empty cell. So we're starting with cell 1A. So we will get the path and improvement index for 1A. Improvement index for cell 1A is 50 ringgit. Okay, so we have to continue do this for empty cell to A, to B, 3C, 1D and 3D. So we will get the improvement index for each of the empty cell. So it is optimal if all improvement index is greater than 0. So since we are get negative value, so it is not optimal solution yet, so we have to continue for the second iteration.
At second iteration, we did the same step of first iteration. Then at 1D, we replace minimum number of negative value. So at 1A, we plus 1, minus 1, plus 1, minus 1 and go back to 1A. The improvement index we got is 50. Then we calculate all the improvement index, we get negative value at 2B. So we need to do third iteration. At 2B, we replace minimum number of negative value. So at 1A, we plus 1, minus 1, plus 1, minus 1 and go back to 1A. The improvement index that we got is 50. So we calculate all the improvement index, we got negative value at 1C. Again, we do fourth iteration. At 1C, we replace minimum number of negative value. So at 1A, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1. This is the long path. Why I did not minus here, because there is no value. So I need to find another cell to minus. As long as your supply and demand are balanced, so the improvement index is 100. We calculate all, we got positive. Then we calculate the total cost. We got 20,200. Thank you.
Hello, my name is Ahmad, Ridwan, Firdaus, Mahyuddin. So today I will use Excel solver to solve the problem that we choose based on the child fair company question. So let's get going, right? I already set up all the information over here, and now all I need to do is to find the total cost of all of this shipping model and cost. So that use some product function. Then we can pick all of this yellow, I would say yellow area, and this green area. So we get the total cost of 6,600. And then after we got all of this, as you can see, we can go to our solver right here. So our objective is to know the total cost, so I want to pick this as my total cost, and we want to minimize the cost. So for the changing variable cell, which one? We want this green area to be our changing variable cell. So now we want to add some constraint. So the first constraint is the shipping, so must be smaller or equal to this supply, and we add another constraint which is involve the receive, and I want to be it's greater or equal to the demand. Yeah, and then we click OK. So we get all of this constraint and variable cell, and we want to do this as a simplex linear programming. Okay, we have here to make sure the non-negative variable, and we press solve, and then we already this. So you want to keep the sensitivity report so you can see what's going on in here. Click OK, and boom. Yeah, so the optimization is at 20,200. As you can see, is yeah. So this is your answer. Thank you.